So two things are going to be happening in this video. One, I want to say thank you. I appreciate that. I think everybody out there that is doing things like I'm doing, go out there and let them know that you appreciate what they're doing, because it does take a lot of time and effort to do this, and we're not getting paid. But we really want to educate people out there. So again, I appreciate that. Now what we're going to do is we're going to actually show some of the images from the equinox with the equatorial sundial, and I'm going to also show it on a flat earth and how it doesn't work. So let's get started. Again, here's my images. I actually have these updated on my website if you want to go there. But we have, well, actually, let's do that. It'll probably be easier. Let's go to documentation, March 2026, right here. So what's going to happen is you're going to see these images here. So we're going to demonstrate or observe a shadow going completely from the west to the east during these photos. So I'm going to try to go through these as fast as possible, but you see 9:41, here's at 11:12, again 11:12, 11:12, and then here's at 4:13. So it's going in a straight line across from west to east, 55-degree angle at the 35th latitude north. Now, here's what I've done, is I've taken the same sundial, angled it at 55 degrees, and I put the sun in the position that it would have to be for it to do the same type of observation. So what we're going to notice here is we're going to notice that the shadow is going from the west straight through the sundial into the east, just like we observed it outside. I'm going to do this one more time. Let me see. Well, I can kind of speed this up a bit. So here it is, going through, going through, going through, going through, and going through, and going through, and then coming back through there. So you see how this is doing that. Solar noon, it's right up and down, and how that's going out like that. So now let's go back and look at our photos. There's that right there happening. And as you go to throughout the day and going back to the morning time, we see that same thing happening. Okay, so all of this that's happening in reality, right, is I can replicate it here. Okay, this is exactly what's happening. But what did I have to do to make that happen? Well, let's look at it from the side. So I had to make the sun match the angle from here to here. The sun has to stay on this angle in order to work. So just for reference, to make sure you know that the sun is going directly there, that is the rotation of this object here. So let me highlight it here, right? Highlight it here. Its rotation is at 55 degrees. So that's just to let you know that the sun is hitting where it's supposed to be, and I'm not doing any funny business. But for that to happen, the sun has to do this. The light source has to hit it just like this. And when we do that on a flat earth or any type of flat plane, it's going to fail. It matches observed reality, but it fails in flat earth ideology. Now, what the flat earth says that the sun actually is doing is this. Do you see this sun coming around? Now, the sun that goes in a circle above the flat earth will not create a straight line shadow angle. Let's take a look. Okay, so let's kind of stop it here. Let's go back and see that again. 55-degree angle. The sun's at the same position at solar noon. All right, 55-degree elevation angle. But when we look at the shadow during its path, since it's going in a circle, the shadow's hitting here, coming to solar noon, and the shadow's coming back down. And then you notice that up here, we are getting sunlit on the top of this dial, which is not what we observed on the equinox. On the equinox, the sun never creates light on the face on either side, right? Doesn't do it on either side. But if the sun is rotating in a circle above us, it's going at some point in time hit the face of the dial, right? It will at some point hit the face of the dial. So let me get it right where you can see it. You can tell right here, we have the face of the dial getting hit by the sun. So it just doesn't work on a flat Earth. So to recap, an equatorial sundial disproves a flat Earth. The sun's measured position in the sky disproves flat Earth. Observed, measured reality disproves flat Earth. You guys take care. Have a great day.